A very good morning to Dr. Muhammad Ilman Hakimi Chua bin Abdullah. We are from class Bmmm session 1, 2, and we are in group 5 of the lab session. Today, we will do a discussion about the lab 2, which is case study in lab RDE elemental analysis. So first and foremost, let me introduce myself and my group mate. My name is Ip Yun Yu, and I'm from class Bmmm session 1, 2.
My name is Piramin Tirith and my matrix number is B091810023.
My name is Vinod Kumar Rajendran. My metric number is B0918103441. I'm also from Bmmm S1/2.
My name is Tuan Ismail bin Tuan Zakaria B09181047 and also from BMM M12.
My name is Rutiran Analaki Anbolagan. Entry number is B09181037. I'm also from class 4B section 1/2.
Okay, let's first look at our case study. Our case study to solve the oil and wear debris analysis issue is on the second lab, which is RDE elemental analysis. RDE stands for rotating disk electrode, and as the name suggests, this technique utilizes a high purity carbon electrode to transmit high voltage electricity across a small gap to a nearby carbon disk, where when the electricity arcs across the gap, it actually creates a high temperature plasma which emits unique light waveforms, which in turn gets analyzed through cameras in the equipment. Sophisticated spectral analysis software processes the CCD spectra to precisely determine the concentration of dozens of elements within the sub-ppm precision. To answer the question on why we need to study RDE, RDE elemental analysis is needed to determine the elements in an oil, where the RDE data can then be used to determine the oil contamination level and to determine whether the oil can be used further or it needs to be discarded. The results of a spectrometric analysis are typically reported in ppm, which is parts per million. The resulting data may indicate a wear mechanism such as normal wear, or it may point out excessive wear that potentially becomes a serious problem in its early stages. With this advanced warning, steps may be taken to solve the oil and wear analysis issue. Next, the equipments used for the RDE analysis are spectral Q100 machine and oil samples which are usually new engine oil or used engine oil, where the data from both of these samples are compared. At the core of the spectral oil is a precision rotating disk electrode. Optical emission spectrometer can measure sub-ppm elemental concentration with high purity carbon electrodes. It detects elements in solution or particles as large as 10 millimeter with RDE precision pulse-powered high-temperature plasma and accurately identify elements in a wide variety of substances without sample preparation or dilution. So next, Vinod, could you let us know the introduction of the RDE?
Sure, Praveen, thank you. Let me explain about the intro of this lab. Okay. Elemental analysis works on the principle of atomic emission spectroscopy, which is can be shortenly stated as AES. Spectroscopy is a technique for detecting and quantifying the presence of elements in a material. Spectroscopy utilizes the fact that each element has a unique atomic structure. In lubricant analysis, this method primarily utilized to trace levels of one metals from the moving parts, additive element levels, as well as contamination in oil. In AES, individual atoms within the sample are excited using a high energy source. The atoms absorb energy from the excitation source and then transfer to a high energy electronic state. Due to the laws of quantum physics, atoms do not like being in these excited states and rapidly lose the energy they have gained. they lose their energy that they gain by emitting the light energy. The energy of light emitted, which is inversely proportional to the wavelength, is dependent on the electronic structure of the atom and is thus different for each type of atom. So, by measuring the amount of light emitted to the characteristic emission wavelength for atoms such as iron, copper, zinc, and sodium, the concentration of each atom can be determined. Okay, now let's talk about the objective. The first objective is to analyze elements traced in lubricant samples. And the second objective is to analyze source of trace the elements. Okay. Next, Tuan Ismail, could you explain about the methodology?
All right, thank you, Vinay. Okay, so we move to the methodology that is procedure for this experiment. All right, before we starting the experiment, we must clean the spectrometer lens to make sure it is clear from debris or contaminants. The next one is the oil sample A1, we take it and we shaken it thoroughly to ensure all its elemental contents are distributed evenly throughout the oil. And the next is we place the cap on the cap holder and feed it with the oil sample A1, ensuring it is filled to the brim. Next, a graphite disc. We place the graphite disc on the shaft inside the spectre oil Q100, 100, that ensuring it is insert fully until the slot on the shaft. The next one is the graphite rod. We sharpen the graphite rod and polish it and ensuring it was smooth, clean, and shiny. The next one is the graphite rod was then we clamp the graphite rod inside the spectre oil Q100 and ensuring that the clamp level is upwards and the graphite rod is touching the graphite disc. After that, we clamping, the clamp level was lowered to create a gap between the graphite rod and the graphite disc. The next one is the sample of cup holder together with the sample cap was we place it under the graphite disc, which was we raised to partially submerge the graphite disc in the oil sample. The next one is the Spectre Oil Q100. We close the Spectre Oil Q100, the door, and the burning of the oil initiate through the computer. And the next one is when the oil is burning inside the Spectre Oil Q100, the elemental reading for A1 oil sample is recorded and tabulated in table 1 by the computer. The next one is when A1 oil sample we discarded together with the sample cap and the sample cap holder, we clean the sample cap holder. After we all do the step 1 to step 10, so we move to step 1 to step 10. We repeat it for the F1 oil sample, and after the experiment was done, the Spectre Oil Q100 and the sample cap holder, we clean it thoroughly. All right, so we move to Yip Yun Yu for the result.
Okay, thank you to Ismail for the methodology part. So now it's my turn. Since I'm sharing the screen, so I cannot show my face. So as you can see in the report, we use two types of sample oil, which is A1, the new engine oil, and F1 used engine oil. After the lab session, we found that each element has its own limit value. Some of the element we did it in the lab doesn't fulfill the range of the limit value. So we find on the website. For example, the manganese, we found that the new engine oil A1 was 2,487 K, while the sample F1 was 337 K. But the range of the limit value in the website is 1 to 3. So why the wear level happen on the lubricated components? Because the engine wear and tear is an unavoidable part of engine operation. Nevertheless, with the proper knowledge and engine oil, it is possible to manage the rate of wear and maximize the engine's life and performance. A heavy-duty engine, like any internal combustion engine, contains a large number of moving metal components that slide and scratch against one another. They are separated by a very little space and tolerance, however, it is sufficient to enable a tiny film of lubricant to form between the two metal parts, allowing them to move against one another without touching. Increased engine wear results in the loosening of those tight tolerances. It generates additional space, making it more difficult for the oil to seal the engine's different moving parts. So the reading of calcium in our experiment in sample A1 is 327.99, while for the used oil sample F1 is higher than used oil sample A1, that is 1,485. Calcium is often found in a conjunction with magnesium and forms the detergent and corrosion inhibitor part of the additive package. So for the aluminium, A, A1 used oil sample is 12.15, while used oil sample F1 is 4.40. Aluminium is primarily from piston, oil pump housing, oil coolers, torque converter parts, cylinder blocks of all aluminium engines, and thus containing bauxite. So, um, below the poster is the analysis of the graph. So the most significant reading is calcium in sample L1 is 327.99. So the graph you can see as shown in the table, while for the used oil sample F1 is higher than used oil sample A1, that is 1,485. So the calcium is always in a conjunction with magnesium and forms the detergent and corrosion inhibitor part of the additive package. So why the trace element occurs? Because oil analysis is used to determine metal wear. Despite the oil covering, frictional wear occurs when lubricated surfaces more relative to one another. So metal identified include copper, the main constituent of brass and bronze, as well metal from oil pumps connecting rod bearings, pin bearing, rocker, arm, shaft bearings, and so on. So it is most often caused by a leaking water pump or coolant coil in engines. Lead, usually in combination with tin and or copper connecting rod bearings. So there's highly oxidized engine oil that damaging the bearing material. So that's all for my part of analysis. I will pass the last part to Rotiran. Rotiran?
Thank you, Junju. Okay, in conclusion, the fundamental requirement of this testing was evaluate the wear condition of equipment. Wear particles were formed throughout the lifetime of oil-soaked equipment. With the nature and rate of wear shifting from the time the equipment was first used to the time it was shut down. Spectroscopy is the method of determining the extent of wear on a piece of equipment. Component can be identified and quantified using a spectroscopic approach. The rotating disc electrode (RDE) method, which was particularly developed to burn out any leftover element in the oil. was used to detect the element in the oil using high purity carbon electrode. Experimentation was utilized to identify the oil constitute using this method. Using this procedure helped determine the suitability of the oil for usage in the machine or system under evaluation. These testings will also simplify any judgment about oil selection that are required. When it comes to any moving mechanism system, it is critical to verify that the oil in the system is of the correct quality and it is in good working order. Thank you.
Okay, so a very big thank you to me and my teammates, and also thank you to Unjet Sheikh for guiding us in the lab to RD elemental analysis. So that's all from our presentation. Thank you.
Thank you.
Thank you so much.
Thank you.